Hello everyone, welcome back on series of video lectures on rock mechanics and strata control. Okay, let's move on. In previous lecture, in previous video lectures or video tutorials have covered the following topics. Let's recap. Let's recap a few of them. Like in last video lecture, we have covered a Moore circle. The significance of Moore circle while representation of what you call the stresses acting on a two-dimensional block, and what are the various sign conventions that we use to draw the Moore circle, that we need to follow to draw the Moore circle, and the procedure to draw the Moore circle. And apart from that, we solved simple numerical problems based on Moore circle. Next, we also discussed about the Morse envelope. Morse envelope is nothing but what we'll draw what you call series of Morse circles under various under different conditions, and a common tangent to draw. Common tangent is drawn to all the circles. Whatever the common tangent drawn to all the Morse circles under various conditions is known as Morse envelope. Generally, the line of Morse envelope is not straight line; it's a curved one. But in our generally in our usage, okay, we'll be treating it as a straight line. Okay, and in order to make any kind of interpretation, we'll be treating as Morse envelope as a straight line instead of a curved line. Okay, from the Morse envelope, we'll determine the following two parameters. Basically, like angle of internal friction and cohesion. So if from the Morse envelope, like along the failure plane in a two-dimensional block of rock mass, okay, what would be the what you call angle of internal friction along the failure plane, and the cohesion that will be acting along that plane. These two internal parameters that we can determine what you call by plotting the Morse different Morse circles and from Morse envelope. Okay. Then we discussed in brief about the stress distribution around a mine openings, mainly in case of narrow opening. Okay. Next, as part of this video lecture, let us discuss about the stress distribution around mine opening. Like I'll reiterate on the stress distribution around narrow opening once again as part of this lecture. And apart from that, like in detail I'll explain about the stress distribution around a wider opening. Like in mining activity, whatever the opening that we made, if it is of a wider one, then how exactly the stress distribution is going to be. In case of Longwall, in case of Longwall is a method of mining wherein the entire face having a length varying from 100 to 150 meters can be extracted in a single stretch. So that kind of opening is known as a wider opening. In those kind of mining situations, the stress distribution would be somewhat different. So we need to analyze and we need to in detail we'll discuss about that. And soon after completion of that finishes with that we'll be done with the second chapter. Then we'll move on to the third chapter, like which basically deals with the physico-mechanical properties of the rock mass. So depending on the time availability and like I'll try to cover this part as well, part of this part. Okay, now coming back to the stress distribution around narrow opening. So in a board and pillar method of mining, okay, whenever look at here, just a minute. See here, let's say this is the opening. I made it. The same thing that is being represented as part of this diagram as well. This is the opening. Sorry. Okay. Okay. See here, in case of board and pillar method of mining, see board and pillar method of mining, as we know, like it's a method of what do you call developing the coal deposit, by driving a smaller roadways into number of pillars, and later depending on the strata condition and all, we'll try to what you call extract a pillar. Okay, so during development stage, whatever the what you call the smaller opening that we made. we need to analyze how exactly the stress distribution is going to take place. So in case of under in situ condition, like before making a mining before performing the mining activity, that is nothing but a pre-mining conditions. Under pre-mining conditions, what are the stresses that were acting? What are the stresses that were acting? Let us say in this case P1, P2, P3, P4. Just a minute. Let me call this as one sec. Okay. This is P1. This is P1. P2. This is P2. In case of 2D plane, okay, if you look at this diagram, like P1 are the vertical stresses which are acting in a vertically downward direction, and P2 are the stresses which are acting in the lateral direction. Okay, if you take the other dimension, let us say what you call the force that is acting, or the stress that is acting in the other direction is P3. So under equilibrium conditions, whatever the vertical as well as the lateral forces, they are in equilibrium. That's nothing but P1 is equal to P2 is equal to P3. So, okay, then what happens, right? Whenever we make an opening to carry out the mining activity, whatever the forces that were in equilibrium, they get redistributed. They get redistributed up to certain extent. Okay, whatever the remaining portion which not got redistributed to the adjacent pillars or to the adjacent in situ pillars that were left. Okay, that we need to be controlled by understanding the behavior of the rock mass or the overlying strata under various mining conditions. Here, let's move on. Okay, this is about that. Next, move on. Okay, now look at here. The effect of let me take this over here. Okay, the effect of P1 is compressive, compress the rock in a vertical direction, and the strata is not able to expand the sideways because it is trying to push like this, and there won't be any, no, it won't be trying to, because it is trying to this one, and it is supposed to move like this. Well, what happened? Not able to expand sideways, and there is induced lateral compressive force. This one P2 along the bed denoted by B2, which got induced now. This force is called lateral forces. Okay, when an underground roadway is made in a mine, this is what we already discussed. Let's see, when an underground roadway is made in a mine, the equilibrium of the pre-mining force is distributed and is disturbed. Sorry, the equilibrium of pre-mining force is disturbed, and there is a redistribution of vertical and lateral pressures. And new kind of forces also come into the play. So what exactly it means? Like what are the forces, as I said earlier, like what are the forces before carrying out the mining activity? There's nothing but the pre-mining. What are the forces which were in equilibrium? Okay, they get disturbed, and then they'll try to what you call redistribute. The redistribution of pressure is explained by the pressure of theory as illustrated in the below figure. Let's see, let's move on. Okay, look at here in this diagram. Okay, let's clear the drawing. Okay. Now in this diagram, look at here. Just a minute, let me remove this one. Okay. So this is a kind of opening that we made. So this is what exactly opening we made. Okay. So whatever the forces which were acting initially vertically, it was like this. It was like this. It was like this. Like this. So before carrying out the mining activity, the forces acting was like this. Now what happened, right? The moment you made this excavation or the narrow opening, the vertical forces which were acting, vertically downwards, like P1, okay, they gets what redistributed in the form of a curved path. That's what exactly it is. They got redistributed. So look at here. This is how it is. and this is how it is, and this is how it is, and this is how it is. It's get redistributed. But is it going to be the complete force is going to redistribute it? No, because only, so look at here, let me choose a different color. Okay, the force, this portion, look at here, this portion of rough mass, because only this portion got redistributed, and this portion still it will be acting vertically downward. It will be like this only. So this is trying to close this opening, because due to redistribution, it's not completely got redistributed. If the overlying strata is strong enough and which can sustain on its own, then we are good to go. But in a situations where the overlying strata is not strong, and there will be a movement of along the layers of the strata due to the lateral forces like P2. So in such a situations, this overlying strata, in such a situations, this overlying strata means this part. This portion is subjected to what? Trying to subject to a downward force, that is called the bending forces. So these the layer which is present immediately above the opening, this layer, this is called immediate roof. And the layer which is present above that, they are known as what we call main roof. So the layer which is present immediately above the opening, okay, this is called immediate roof. So this immediate roof is subjected to what? Some kind of bending forces. Like that's why it is called B, which is acting downward like this. It is something like this, like this, like this, like this. It is moving like this. Because why this force is acting? Because whatever the forces which got redistributed, it's not got redistributed to the complete extent. Only the partial portion of it got redistributed. Look at here. Choose a different color. Look at here. Only this portion, certain extent only it's got redistributed. But this portion still it is acting vertically downwards. So we need to take care of this. We need to analyze the physico-mechanical properties of this. That's what exactly we are going to discuss. What are the physico-mechanical factors that influence the stability of overlying strata? The stability of overlying strata. This will act this one. So since this force, this is trying to act this one, the layer which is present immediately above the opening, it is subject to some kind of bending. So there will be a separation. So as a result, what happens if I won't provide any kind of support? So there will be a separation between the layers of the strata. If you look at this part, let me draw this. Yes, this part. See, this part. So there will be a separation between the layers. So if I want to provide a support due to bending of this one, there is a separation between the layers of the strata. That is known as bed separation. So that is the reason. Okay, whenever you observe in the field, like whoever is the experienced mining engineer or who is the mining experienced mining person in the mine, generally he will be testing the what you call the behavior of the strata by what you call by simply what you call throwing a rod or bamboo stick against the roof. He will hit it very hard against the roof and try to find out the kind of sound that is coming out of the roof. See what happens, right? In case of any separation between the layers of the strata, the sound will be different because there is a gap that got created. If the layers are intact and there is no what you call separation between the layers of the strata, then what happens? Definitely the sound would be different. Definitely the sound would be different. So that's what it is. So this is what exactly the phenomenon. If you go to the field, that is how the people who are analyzing the behavior of the strata. Of course, it's a crude way of it, but it's a what I call hit and trial kind of method actually. Like by virtue of their experience, okay, like by observing what you call the kind of sound after hitting the roof with a rod, okay, with a rod, the kind of sound that will be based on that they can easily identify because it comes by experience. The reason behind it is because if the layers are strong enough and if there is no separation between the layers of the strata, the kind of sound that will be getting is different from if there is a separation between the layers of the strata. The kind of sound that will be getting both are different. So that what exactly makes difference here. So what exactly I mean to say is the separation between the layers of the strata is known as bed separation. Is known as bed separation. Okay. Next one, due to these vertical forces, what are the edges of the opening? Like let me take this. Let me choose a different color. Okay, let me choose this. Okay, here this part at the edges of the opening. This is called bending forces at the edges of the opening. It will the what you call the top layers of data are subjected to some kind of shear. Here it might get sheared off. So these forces, the forces acting at the edges of the opening, that they are called shear forces. Yes, they're called shear forces. Next, as I said, what are the forces which were acting vertically downwards, they get redistributed. The redistributed force that generally that would be acting on the edges of the opening, this portion, immediately the edges of the opening. That's nothing but a portion. See this portion. Let me put this portion, this portion, this portion. So as a result, what happened? Because earlier it was not like this, and this portion got what you call more and more load acting on this portion. So that's the reason it's get bulge. See, if you look at here, there is a bulging kind of thing. This is called abutment pressure. Means abutment pressure is nothing but due to redistribution of the forces. Due to redistribution of the forces in the sides of the pillar, whatever the excess of the vertical pressure or the vertical stress which will be acting on the edges of the opening is known as abutment pressure. This is called abutment pressure. This is called abutment pressure now. Okay. So now having said this, let's move on. Okay. Okay, right. From this diagram, so this we already discussed. If you look at the previous diagram, B means this one, right? These layers which are immediately above the opening, they are subjected to kind of what force? Bending forces. B is nothing but the bending forces whose magnitude increases with the width of extraction. Obviously, the width of extraction increases, the roof span width gets increased. Roof span is nothing but this portion. Look at here, this portion, the exposed roof span. The width increases, the span increases, okay, which is subjected to more and more bending forces. So the bending force that is acting on the layers of the strata or in the overlying layers of the strata, it depends on the width of the excavation, right? If the width of the excavation is more, the bending force will be more because they are subject to more kind of bending force, and as a result, there will be a sag. So that's what exactly it is. Okay. Next one, lateral forces. As I said, P2 is the lateral forces which are acting. See, these forces are P2 is called, they are called lateral forces. P2 are the lateral forces, P1 are the vertical forces. Am I right? Okay. Next one, S is the shear force. See, lateral forces and intensity of which increases with the depth. Yes. Bending forces, intensity of the width. Bending forces whose magnitude increases with, it depends on what? Width of extraction. Whereas the P2 is the lateral forces, intensity of which increases with depth. It depends on the in what depth this mining activity or this mining activity is being carried out or this opening is being made. S is the shear forces. Intensity highest when the coal and floor beds are strong. That's nothing but, look at here, shear force is nothing but, one second, let me clear this. Okay. Shear force is nothing but the forces which were acting at this location. At this location. At this location. Look at here. Suppose if Guys, listen carefully. Why I'm taking so much of time, in explain this, because this is one of the important concept that we need to understand as a mining engineer, and this will be useful. This concept is being useful throughout your career. It will be useful throughout your career. So as long as you being a mining engineer, you must understand this concept, and these concepts are pretty much applicable in the field as well. Okay, look at here. So these are all the overlying strata, and if these layers are very strong, and there will not be any kind of separation between the layers. What happens? This entire beam is a kind of solid beam, and it might get sheared off at this location, this location, and this location. So it's subjected to shear forces at the edges of the opening. That's what exactly the S is. So it all depends on what the types of layers of the strata. Look at here. Look at here. S is the shear force. S is the shear force. Intensity is highest when the coal and the floor beds are strong. If they are strong, okay, it will act like a one composite beam kind of thing. The shear forces that are acting at the edges of the opening, they are more. Next, V1, obviously, vertical compressive forces proportional to the depth. Yes, that's true, right? Because the vertical force, it all depends on what, how much is the load acting due to the overlying strata. It all depends on what the depth of the deposit. If the depth is more, and depth is more, obviously the overlying strata pressure will be more on the opening. Sorry, on the opening. That's what exactly it is. And this opening. Okay. So vertical compressive forces proportional to the depth. And C is the increased pressure, that is called abutment pressure. Yes, this is what we discussed. Due to redistribution of forces, the abutment pressure. So someone might have, generally you might have come across these kind of questions in interviews or in the examination. What exactly abutment pressure is? So you can simply say that due to redistribution of pressure, whatever the excess of load that is acting on the edges of the opening is known as abutment pressure. And you might have come across another important definition, that's called what is bed separation. So in bed separation, whenever you make an opening, okay, if the what you call, whatever the excavated area is not being supported, and the overlying layers are subject to some kind of bending forces. So due to the span of the opening or due to the width of the opening, okay, the overlying layers are subject to some bending forces, and there will be, as a result, there will be a separation between the layers of the strata. So whatever the separation between the layers of the strata that we obtain, that that is being developed, is known as bed separation. This separation is called bed separation. Okay. So this is about the what you call bed separation, abutment pressure, and various important terminology that we might come across on this one. And what is the vertical significance of bed separation in the field? In the field, generally, let me reiterate it. In the field, in order to test what you call the behavior of the strata before, soon after making the excavation. Okay, the experienced mining engineer generally he will hit the roof with a with a rod. Okay, you will hit the roof very hard with the help of a rod or bamboo stick, and try to find out the what you call the resonance or the sound reflection of the sound that will be getting out of it. If there is a bed separation between the layers of the strata, and due to the lateral movement, then the what you call the sound that will be getting out of it will be different. So with that, like by virtue of experience, okay, with the reflection of the sound, we could be able to find out the behavior of the strata. That's what exactly the significance of this terminology in the field. Okay, let's move on. Let's see what exactly it is. In a narrow roadway, as is driven in board and pillar method of working, the vertical compressive forces which are acting in the area of the roadway before it was formed are deflected to the pillars of the cone. Okay, they'll get redistributed after the formation of the roadway. The redistribution of pressure takes place as shown by arrows. That's what exactly the arrows which with this one. Okay, the rocks in the immediate roof bend downwards under their own weight. So that's what earlier, previously we discussed. What exactly? This one. This one. This is called bend. Okay, that's what exactly it is. Okay. The rocks in the immediate roof bend downward under their own weight and tend to separate from one another. Sorry. Yes. So one another. This phenomenon is known as bed separation. This is what I already explained. Next, the weight of the highest strata is transferred to the coal, uh, uh, sides as shown by the curved arrows CC. Okay. At the same time, the side pressure P2, that is nothing but the lateral forces, tend to push the rocks into the roadway. The sides of the coal pillars formed. The sides of the coal pillars formed are subjected to. Look at here. This is very important. Look at here. These are the forces which are acting in vertically downwards. Acting vertically downwards, and there are some lateral forces. The combined effect of this, there are some lateral forces like this, right? The combined effect of F is it leads to some kind of shear at this location. That's what exactly it is. Okay. See, at the same time, the side pressures P tend to push the rocks into the roadway. The sides of the coal pillar formed subjected to shear forces SS. That's very exactly. So there is a vertical pressure, there is a lateral pressure, there is a bending moment, there is a shear forces, and there will be a what you call abutment pressures. So these are different kind of pressures that will be acting. Okay, whenever we make an opening. So initially they were in equilibrium, they got disturbed like anything depending on the width of the opening. Okay. So next one, the immediate roof beds A, B, L, L. There are different layers. Okay, A, B, L, L, M, M, N, N acts as the beams which tend to bend downwards due to their own weight. Okay. Next, the lower layers of the bed are as in the case of any beam under tension, therefore liable to fracture. To prevent lower, because they are subject to bending forces, to prevent the lower layers from excessive sagging, because they will try to close the opening, excessive sagging and ultimate fracture. Ultimate fracture. Support has to be erected in the roadway. This is very, very, very important. Generally, in interviews or wherever we go, we might come across the general question, okay, that interviewer will ask is why we need to provide a support. Whenever we are making an opening, why we need to provide a support? What happens? What happens if I want to support the excavated area? That's what exactly the kind of questions we might have come across in any interview. So to answer that question, you need to understand this. I already explained it. Let me. So as I said, there will be a vertical as well as the lateral movement. Okay, and vertical, these layers are subject to some kind of bending moment. The layers, if this is not properly supported like this, if I won't provide any kind of support, this kind of support, because there it is trying to act like this, which is a different color. This bending force are acting like this, and I'm trying to what you call counter those bending forces to stabilize the roof or to stabilize the excavated area. So what I'm doing now, I'm trying to what you call provide a support. If I provide a support, what happens? These layers will be intact. There will not be any kind of separation. There will not be any kind of separation. If I won't provide a support, what happens? There will be a separation between the layers of the strata. So to answer the question, like what you call, due to redistribution of the pressure and to avoid pressure and with the presence of the vertical as well as the lateral forces P1 as well as P2, there will be a separation between the layers of the strata. Okay, that separation is called bed separation. So to avoid bed separation, and to carry out the safe mining activity, we will be providing the supports. So the answer to the question is to avoid the separation between the overlying layers of the strata, and which leads to a roof fall, if it's not properly supported. To prevent that, we'll be using the supports. That's what exactly the answer is. Okay, let's move on. Clear drawing. Okay. Now, That's what exactly sagging and ultimate support has to be erected in the roadway. The redistribution of pressure on the formation of a gallery because the excavation that is made in a board and pillar, that is called gallery. Okay, the smaller opening that we made it gallery in an underground coal mine, resulting into 5 zones of influence. So the entire this picture is being divided into 5 zones. This is zone 1. This is zone 2. This is zone 3. Okay, there is another zone that is present in the bottom, which is not there in the figure, and that is zone 4, and this is zone 5. The zone 5. So total 5 zones. The entire picture is being divided into 5 zones. That's what exactly the next slide so reflects. See here. Okay, there are 5 zones of it. Zone 1. Zone 1 is the lower one. The bed separation in the immediate roof started due to different sags of beds. That is zone 1. Zone 2, no bed separation through the strata sag slightly due to gravity. No bed separation. Look at here, what is zone 1? This part. There will be separation. This portion is called zone 1. In the upper layers, obviously, this what you call this separation will be extended from the in the upper layers up to certain extent. It won't go up to the surface, right? So the separation will be this one. In this zone, there will not be a sag, but no separation. They are intact. So that is called zone 2. Okay. So zone 1, zone 2. Let's see. Okay. Zone 2 is no bed separation through the strata sag, through the strata slightly due to gravity. There will be a sag, but no separation. Okay. Zone 3, horizontal vertical pressure built up to the excavation value. That's nothing but the in zone 3, whatever the vertical forces they get redistributed. Okay. Next one is that's what zone 3. Look at here. This is called redistribution portion. This is called zone 3. Okay. Next, zone 4 is present, as I said, it's not in the picture. It's present in the bottom, which is something like what we call, it's related to the floor. Because these forces, and if the floor is not strong enough, that leads to what the heaving of the floor. If the floor is strong, there won't be this one. Of course, because floor is present at the bottom, there won't be any separation. Am I right? Okay, look at here. The floor heaves up, but there is no bed separation on the floor, obviously, because if the floor is not strong, it will comes up. Okay. Next, zone 5. The pillar bulges towards the galley due to release of horizontal stress at the pillar sides. This is called abutment pressure. So this is what exactly the pillar bulge, because the whatever the vertical forces that got redistributed and they will be acting on the on the edges of the opening, the portion where it got redistributed, there will be an excess of load that will be acting on it. Okay, as a result, the pillar bulges towards the gallery due to release of horizontal stress at the pillar sides. The dotted line represents the pressure arch or the pressure dome with its supports or abutments situated at the sides of the coal pillar. Look at here. That's why it is called, this concept is also known as pressure arch theory. If someone explains the pressure arch theory, it's the same as that of pressure stress distribution around a narrow opening. See this one. This is a kind of arch that you will be getting. That's why it is called different arches, redistribution. So that's why it is called the pressure arch theory, or it is also known as dome theory, because you are getting a shape of a dome. That's why it is called, it's also known as the dome theory. Look at here. The dotted line represents the pressure arch or the pressure dome, with its supports or abutments situated at the sides of the coal pillar. Okay. Now let's move on. That is about that's all about the vertical stress distribution around the narrow opening. Let us discuss further. If the opening is wider, means it is not a smaller opening. See, there was lot of disturbance even if the opening is small, because we are disturbing its original condition which were in equilibrium, and we are disturbing it, and as a result, what happens? There will be a lot of disturbances due to what is the type of overlying strata that we might come across. Okay. So the stress distribution around a wider opening or longwall. As I said, in case of longwall is a method of mining. Okay, mainly in case of coal, where the what you call the length of the face will be what you call the length of the excavation will be 100 to 120, minimum of 100 to 120, 150 meters. So which is a huge face that will be extracted in a single stretch. So that kind of opening is called wider opening. In such a situation, let us discuss in such a situation how exactly the pressure distribution is going to take place. Okay, so look at here. Okay, when a Longwall face is newly opened between two headings, okay, new between two headings are gate roads, okay, which are what you call generally 100 meters apart. So generally, how exactly the Longwall takes place? Let's see here. Let me draw this. Yeah. Let's say in case of Longwall, there will be this is your face kind of thing, and there are gate roadways. Let us say this is what is. So this is called a main gateway. This is called tail gateway, and this is your face. This is called face advancement. So this opening, the one which you are seeing here, sorry, this opening is called wider opening. This part, this entire length, because it is a very big 100 to 150 meters. That's why it is called wider opening now. Okay, so now look at here. These are the gate roads. Gate road method, there will be two headings. One is this and one is this. When a Longwall face is newly opened between the two headings or gate roadways, which are generally 100 meters apart, as the face advances from solid coal pillar or coal rib, as the face is moving, what happens? There will be a huge gap. Right? Initially, it was like this. It was like this. We made this opening, and this is moving up. This is called the rear part of it, and this is called the front part of it. Correct? This is called a rear abutment. This is called a front abutment. So there will be a lot of separation as this face moves. Okay, look at here. It's a general 100-meter face and the face advances from the solid coal pillar or coal rib. The higher strata in the roof form a sort of bridge. It forms some kind of what cantilever. So what exactly it means? Let me explain it. Okay, let me explain this one what exactly it means. Okay, let's say keep this something aside. Take this. So different layers. Like this, we have different layers. So this is the rear abutment part of it. So now what happens? This is the front face. This part, the first part of it, and this is the rear part of it. So now what happens now? Forces get. Sorry. Okay. Okay, forces get redistributed like this. It gets here, and they move like this in the other direction. So the forces, as I said here, they will get like this here. They'll get that. I'll explain the vertical slides. Okay, what exactly I meant to say? In case of wider opening, this is the vertical moving face. This is the rear face. This is also called front abutment. This is also known as rear abutment. So as this face moves forward, okay, there will be a redistribution of pressure. There will be a redistribution of the pressure. Let's see. Let me 1 second. Okay, let's discuss further. When a Longwall face is newly opened between the two headings or gate roadways, which are generally 100 meters apart, and the face advances from solid coal pillar or coal rib, the highest strata in the roof form a sort of bridge. It's nothing but it forms a kind of what you call cantilever. It's a kind of overhanging beam. Okay, it's here it is mentioned as a bridge or the arch across the excavated area from a solid coal face to the coal face to solid coal coal of the coal pillar or coal rib behind. And is nothing but that is nothing but front abutment and the rear abutment. The power supports are used to support the immediate roof. In case of longwall mining, power supports are used. As the face advances and the span of the arch increases, the span of the arch increases, the load due to upper strata increases over the abutments of the arch until the overhanging roof breaks. What exactly is the overhanging roof? That's nothing but what exactly the overhanging roof? Overhanging roof is nothing but this portion. Look at here. In this case, generally, what happens here is okay. Get one bigger kind of thing here. Yep. And, something like this. Take this. Put it like this. Put it like this. And there are different kinds of this one. Like this. Like this. Now what happened? If I won't provide this support, what happens, right? It acts like a kind of what you call this part. But this portion will act like kind of if it won't fall, it will bend like this. It acts like this. So it acts like a kind of slight bend. So it will sag like this. So it acts like what you call like this. It will bend. It will bend like this. It will come down. So this is called, or this portion is called overhanging reef. Okay, this has to be collapsed. Otherwise, what happens? If the overlying strata is not collapsed and it is hanging between the front and the what you call the rear faces or front face and the rear abutment. What it does now, there will be excess of pressure acting on the front part of it. So that's what exactly it is. Okay, so okay. So as the face advances and the span of the arch increases, the load due to upper strata increases over the abutments of the arch, over the abutment of the arch until the overhanging roof breaks and the roof comes down in the gove. The redistribution of forces is shown in the below figure. Look at here. This is what exactly I was talking about. This is called the overlying this one. Let me annotate it. Take this to up. So it was overhanging like this. So if it is not collapsed, this is a go failure, right? If it is not collapsed, then what happens now? There will be a overhang kind of thing. That's why it is called the overhang. Here it was mentioned. There it was mentioned like what you call bridge kind of thing. There's nothing but an overhanging beam. So as the phase advances, as the phase advances, the load acting on the abutment gets increased. Look at here. This is called front abutment. Okay. So between A, B, there will be an increase in pressure because overall stress get redistributed. Some portion will be acting on the what you call front abutment, and the other one is this one. If this portion is what you call the overhanging beam due to what you call overlying strata, if it is not caved or if it is not break down into the gulf area, then there will be excess of pressure will be acting on the faces. So this has to be collapsed to release the pressure. Okay, there will be redistribution of the pressure now. Okay, so look at here. Apparently, this diagram indicates what the load that is acting on the front abutment, which got redistributed. That's what exactly this curve represents. There will be a maximum on the faces at the particular somewhere what you call behind the face, somewhere behind the face, somewhere well in advance of the face. This portion, there will be what you call more and more pressure will be acting on it. Same way, what you call in the working area. The beauty of it is in the working area, this portion, the load that is acting will be less. Load that is acting will be less. And from this, if you look at the rear one, okay, here it will be maximum, and it's get reduced here. And from the golf area and toward the back abutment again, it will get increased because it's got reduced. That is what exactly this curve is. So why there is a zero? Because this portion in this figure, it's got caved. There is a collapse. There is a due to collapse of the immediate roofs. What happens? There will be a release in its pressure. This pressure got released. Its pressure got released. So as a result, what happened? This will be zero. Okay. This I will be explaining in the coming slides. Okay. Here. Look at here. The redistribution of forces is shown in the figure. The dotted arch is represented as pressure arch. Pressure arch is nothing but this part of it. This part, the dotted part, this is again similar way here. In this case, it is a wider opening. In the earlier case, it was what you call the narrow opening or the smaller opening. Okay, this is called this is called as a pressure arch now. Okay, look at here. So the redistribution of forces as shown in the figure, the dotted arch is represented by pressure arch. The weight of the higher bands is carried partly by the solid core at some distance ahead of the face. That's what exactly. And between B and C, between ahead of the face, between B and C. What exactly is? See here, between B and C, if the abutment pressure will be maximum here, it will carry ahead of the face. That's how it is. Between B and C, and partly by the pack. That's nothing but the back rear part of it by the packs at some distance behind the face. That is between M and E. Where is M and E? This one. This portion. You got this one here, and the maximum portion is here. Okay. Next, the pressure thus has its front abutment in the solid core, and shifts because the front abutment gets shifts as the what you call the face advances. Okay, it also has a back abutment on the packs in the goof. Look at here on the back side. This is called the back abutment part of it, and this is called the front abutment part of it. As the face advances, the front abutment portion gets moved. It keep on moving. Okay, it will move further and it will keep on changing with the progress of the face or with the advancement of the face. Okay. Okay, this back abutment also, with respect to the front abutment, obviously the distance between the front and back abutment increases. So the back abutment also move forward as the face advances. In the above figure, the line XY represents the static load due to depth of the seam, called dead weight of the strata. What exactly is that? Look at here. Line XY, this one. This is called the static load now. This part. Okay, with respect to this, if I draw this diagram, this is called the front abutment part of it, and this is called, let me move this. Okay, this is called the back abutment of it. This is called the static load. It will be maximum here. At the working area, there will be less, and it will be zero due to collapse of this roof. It will be less, and it will increase further, and and the abutment pressure will be maximum. Again, it will reach maximum in the back abutment part as well. Okay, so Next, the front and back abutment pressures are much in excess of the static load. In the working area CD, the load is greatly reduced because as I said, okay, due to what you call there is an immediate roof that got collapsed, so there will be a stress release in that. So there will not be any what you call excess of load that would be acting on the working area. So that is the reason in the working area CD, the load is greatly reduced, and in the GOF, the load increases till it reaches the maximum. Okay, at the back abutment between A and B. That's what there was a curve like this. It was moved, and it was this one, right? Okay, just as there is a longitudinal pressure arch at the right angles to the face, because there will be a lateral pressure, right? As discussed above, there is also a transverse pressure arch which spans the whole face. Pressure due to redistribution of the pressure, there will be a kind of what the pressure arch which spans whole the face length and has its abutments in the solid coal beyond the gate roads. Okay, experience shows that the pressure arch in Longwall workings has an apex or crest at a maximum height above the sea. This is very, very important from examination point of view as well as from any entrance point of view. So what exactly it is? Experience shows that the pressure arch, okay, the pressure arch in Longwall workings has its apex or crest at a maximum height above the seam is at nearly 2 times the length of the face. So it reaches like this. This pressure arch, the dotted line, right? Okay, it reaches maximum. How much is this? This apex. This is nothing but the 2 times the what is the length of the face. That's where the apex is going to be. The length of the face is L. This is going to be the apex portion is how much it is going to be? 2 times the length. That is where exactly it's going to concentrate. It's going to concentrate now. Okay. So experience shows that the pressure arch in the Longwall working has its apex or crest at a minimum height above the sea. Okay, at nearly 2 times the length of the face. That's where exactly its peak or apex is going to be. Pressure arch apex is going to be. Okay, if the depth of the coal seam, if the depth of the coal seam exceeds the twice the length, the pressure on account of weight of if nothing but what you call in case of greater depth. Okay, the pressure on account of weight of the rocks outside the pressure arch is transmitted to abutments. Okay, and if the depth is less, the static pressure of rocks above the cove area right up to the surface is to be supported by the Chapter support, because the depth is less and there will be caving. That leads to what? Of course, there won't be any vertical abutment pressures, but that leads to what? There will be a development of cracks, and which will what you call propagated up to the surface. So that leads to what you call some other complications. Okay, to carry out the mining activity, the cracks developed onto the surface. There will be air leakage into the GOF area, which leads to some kind of what you call spontaneous heating kind of thing. If you know it, this is what the kind of what you call the uh, kind of experience we faced while carrying out the Longwall mining activity in case of VK7, Padmavati, VK5 or VK7, if I'm not wrong, of Kotham area. Initially, this started, and the depth was very less, and there was a vertical rate of vertical extraction was very fast. As a result, since the depth is less, the cracks were propagated up to the surface, and which leads to what you call the leakage of air into the roof area. Okay, so that's this one. Next, perhaps the reason for Longwall face with caving has caused difficulties in the roof control if the depth of the seam is less than 100 meters. That's what it is. In case of shallow depth, okay, there will be a propagation and propagation of cracks onto the surface, and which leads to further complications. So this is about this one. Okay, this part I'll be covering as part of next video lecture, guys. Okay. Hope I have covered, I have explained in detail about this, because these two concepts are very, very important. Hope I have explained in detail about the stresses that were acting around the faces in case of Longwall, as in case of vertical narrow as well as the wider opening. Okay, thank you so much. Thank you.